this method, but this is a much, much faster method once you get the hang of it. I do want you to try it a few times. That's what I'm expecting you to do. Try something different, see if it works. If eventually you want to go back to the old way, that's fine. But I have found that it's much more likely that students make mistakes using the old way, especially when we're dealing with big numbers. Okay? Let's look at another example. All right. Let's look at an example with 3 numbers. I want to look at 4, 20, and 24. Okay, you're going to pause the video again and work out the prime factorization of each of these numbers. Once everyone's had a chance, play the video and see how it goes. All right, let's break down our prime factors. For 4, we get 2 and 2. Okay? Those are the prime factors of 4. For 20, we should have gotten, let's see, 10, 5. You should have gotten 2 times 2 times 5. Okay? And for 24, let's see, 2, 2, and 3. 2 times 2 times 2 times 3. That should be your set of prime factors for 4, 20, and 24. Okay? And I know I went through that very fast, but I am wanting to show you how quick this method does become. All right? If you made a mistake, go back and check later, see where maybe you missed a factor. So I'm going to draw a line here just to keep these lists separate. I need the common factors. Since I started with 3 numbers, I'm going to have a number common to all 3 lists. Well, I have a 2, and a 2. Okay? So I cross off 2 from every list. I write down a 2. I also have a 2, another 2 common to each list. 2, 2, and 2. Okay. Notice how I have nothing left in this list. I've crossed off everything. You're getting a really bad glare, I think. Sorry about that. So, I will not have any other numbers that are common to my list because I don't have any numbers left here. So, our answer is 4. 4 is the greatest common factor of 4, 20, and 24. Okay, let's see here. One more quick example here I want to show you. All right, let's look at 3, 97, and 5. And I want you to see something right away. Notice that 3 and 5 are prime numbers. Okay? So I'm going to break down their prime factorization. The prime factorization of 3 is just 3, and of 5 is just 5. Notice what happens. I'm not even going to do 97. Is there any way I'm going to have numbers that are common to all 3? Notice that there's no way I'll have a 3 in this list or a 5 in this list. It does not matter what I do for 97. So our greatest common factor of these 3 numbers, if you can't find anybody, the greatest common factor is 1. Okay, I know I went through some of those problems pretty fast. Hopefully you took some time to pause and work through them. Try this method on a few problems. On simple numbers, small numbers, you're much better off doing the old method. Okay? Use the new method when we have 3 numbers or big numbers to work with. Choosing the appropriate method is an important thing to learn in math.